This question tests us on whether we can identify three graphs, essentially among the ones we're given. Now, I think I'm going to do this question by actually sketching each one of the graphs and go from there, because it actually is, it's equally as important to be able to sketch any of these. It's something that's assumed at A level and so on. So, like having a bit of an understanding about what they look like is important as well. It's not just about memorizing. Like with question 17 of the GCSE maths paper, but it's not like, can you remember these graphs? Like that's there a little bit, but can you understand the graphs is even better. So if we got 1 over x, we know when x gets really big, 1 over x gets really small. 1 over a big number is really small. There's an issue when x is 0, so we'll have a discontinuity. When x is really small, 1 over something really small is really big, and therefore we'll get this kind of shape coming out. When it's negative, you get a similar sort of thing going on, but all the answers will be negative and they'll look like that. So in fact, I've got the answer to part A. It's going to be 1 over x. But I've drawn it anyway. And even if it hadn't been the answer, it would be useful to talk about, I think. Cos x. This is one that you should be aware of, and this is a calculator question. So even if you forget what cos x looks like, or you mix it up, you could try some values. So we could put cos of 0 in, and we get 1. So that might remind you, oh, okay, it's like the sine graph, but it starts at 1, and actually it looks like that. You should know cos x looks like this. In fact, it repeats, it goes on forever from then on, it even comes on the negative direction. But what it's not is the answer to B, but we have at least sketched it. X squared is a very classic one. So it's a quadratic and it looks a bit like this. Actually, it looks exactly like that essentially. So any positive quadratic with a plus in front of the x squared, I mean that's hidden here, but it is there, gives one of these. If it was minus x squared, then it would be a sad quadratic, and it would go through 0. We don't have that here, but that's one to know. Oh, okay. I'm going to come back to half to the power x in a second. I'm going to do 2 to the power x to start with. I'm just going to get rid of these now. Dealt with them. So 2 to the power x is known as an exponential, and if we just think about it, 2 to the power of 0 is 1. In fact, anything to the power of 0 is essentially 1. But as x gets big, it gets bigger and bigger really quickly, because 2 squared is 4, 2 cubed is 8, 2 to the 4 is 16. It's jumping up really quickly. Similar happens on the other side, but it jumps down, but not really quickly in fact. But 2 to the minus 1 is a half, because you do 1 over 2. 2 to the minus 2 is a quarter. And okay, to summarize, this is what happens. You get this kind of graph. And that's going to be C. So y is equal to 2 to the power x. Sorry, I put it in the wrong place. Y is equal to 2 to the power x is the answer to C. Why did I talk about that first? Because it's just a little bit easier to explain. If we do a half to the power x, it's very similar, but it's flipped. It ends up looking like this. And the reason is that you could write a half as 2 to the minus 1, and you could write this graph as 2 to the minus x. And it's simply a reflection in the y-axis. And essentially, if you have minus 1, then you're going to get 2. If you have minus 2, you're going to get 2 squared, which is 4. And so you can sort of see the relationship between these two, I hope. This, I'd say, is one of the trickiest ones to identify at first glance. I don't think we're going to talk about it anymore here. Y equals sine x is this one here. I'm just going to go straight for it. I'm not going to do the sketch. If you put in sine of 0, you get 0, and you should be aware you get this sort of wave kind of thing that goes on forever. So dealt with that one. All right, 2 to the minus x. Well, that's interesting because actually I've already spoken that they are the same thing. So this question has just thrown that in, but those are exactly the same graph. A little bit more detail because I can write a half as 2 to the minus 1. And so then I can write half to the x as 2 to the minus 1 to the x. And we know that when we have powers raised to the power of powers like this, that we multiply the powers, and that's where the minus x comes from. Just a little bit more information because I didn't do that before. But they're the same. Tan x is an interesting one. And yeah, probably less common to spend to know than say sine and cos x. I think I see people mix this up, but actually it looks like this. I don't think I'm going to talk any more about why it looks like this at the moment. But yeah, that's what happens when it repeats. So that's what tan x is. X cubed. X cubed is a cubic graph and looks like that. It looks a bit like tan x kind of, but actually, if you put them on top of one another, then they don't. For example, this one goes to infinity at 90 degrees, whereas x cubed just keeps on increasing. It goes to infinity, but not. You can never not like a discontinuity like tan has. But that's x cubed, and finally, 1 over x squared is a bit like 1 over x in the positive, but when it's a negative and you square it, it becomes positive as well. So that's why 1 over x squared looks like that. Anyway, that was I went into more detail than needed here, but it's important to talk about graphs and know their shape, and these are the answers to this question.